is my great pleasure to share with you the new content, Selection of Precipitation Conditions. In the previous chapter, we have mentioned the requirement of precipitation. One of them is to get as pure precipitate as possible. Then, how to guarantee the purity of precipitate? You might think that the control of precipitation process is the key to the purity. That is, controlling the experimental conditions. In other words, it is the choice of precipitation conditions, and this is the topic we are going to talk about today. So, how do we choose the precipitation conditions? Generally, we will use different precipitation conditions according to the type of precipitate, in order to get pure precipitate with ease of filtering and cleaning. For crystal precipitation, the conditions should be considered from the following aspects. Firstly, the precipitation reaction should be carried out in an appropriate dilute solution. In this way, the relative supersaturation of the solution can be reduced, and the precipitation of large particles can be obtained. Meanwhile, the concentration of impurities in dilute solution is relatively low, which can also reduce the amount of co-precipitation. Precipitation should also occur in hot solution, causing a slight increase of precipitate solubility, thus the relative lower degree of supersaturation of solution. It helps to generate a small amount of big crystal particles, and it can also reduce the adsorption effect of impurities. In addition, the precipitation process requires constant stirring, and the precipitation agent should be added slowly to prevent the concentration from being locally too high, which will lead to the formation of a large number of crystal nucleus and amorphous precipitate. At the end of the precipitation reaction, the precipitate and the mother liquor should be placed together for a period of time to make the precipitate pure with completely crystal form. This process is called aging. We know that the solubility of small crystals is relatively large, so during aging, small crystals dissolve and deposit on large particles, making small crystals become large crystals, incomplete crystal into more complete crystal, and metal-stable precipitate changes to stable precipitate. At the same time, the amount of impurities previously adsorbed and clamped into the precipitate can be reduced due to the dissolution of small crystals. However, the aging process may not be effective for the co-precipitation of mixed crystals, and even opposite effect on the post-precipitation. In a word, the precipitation conditions of crystalline precipitate can be simply summarized as dilute, hot, slow, stirring, and aging. For amorphous precipitation, since the solubility is very small and the feature of the precipitate cannot be improved through controlling the degree of supersaturation. Moreover, the precipitate is loose, containing more water, bulky, easy to absorb impurities and peptides. So the main consideration is how to accelerate the coagulation of precipitate particles, reduce the adsorption of impurities, destroy colloid, and avoid the peptizing problem. To solve these problems, first of all, the precipitation reaction should be carried out in a concentrated solution, and the precipitant should be added quickly rather than slowly under constant stirring. At the end of the precipitation reaction, a large amount of hot water is added immediately to dilute solution with stirring to wash the adsorbed impurities into the solution. Secondly, precipitation reaction also needs to occur in hot solution in order to get precipitate of compact structure with less water. At the same time, heating can promote the coagulation of precipitate particles, avoiding the formation of colloid. Appropriate electrolytes can be added during the reaction to prevent the formation of colloid solution. Electrolytes should also be added into the washing solution to prevent peptizing and penetration of filter paper during washing. Volatile ammonia salt are commonly used. Fourth, for amorphous precipitate, aging is not required, because aging cannot improve the shape of precipitate, but make precipitate move cohesive and difficult to wash away impurities. Fifth, in addition, amorphous precipitate generally contains a large amount of impurities. If the accuracy requirement is high, reprecipitation should be carried out. Overall, the precipitation conditions of amorphous precipitate can be simply summarized as concentrated, hot, electrolyte, and no aging. In the process of precipitation, although the addition of precipitant is under continuous stirring, it is inevitable that the local overconcentration occurs the moment when the precipitant is just added. In order to eliminate this phenomenon, we can adopt homogeneous precipitation method. The so-called homogeneous precipitation method is that under certain conditions, the detected ion will be slowly and uniformly precipitated with a slow and uniform production of precipitant in solution through a chemical reaction, rather than reacting with the added precipitant immediately. In this way, the phenomenon of local overconcentration in the solution can be avoided. The precipitate formed is crystalline precipitate, and the particles are large with little amount of impurities, and it is easy to be filtered and washed. For example, when calcium was determined, precipitant ammonium oxalate was added into neutral or alkaline solution to produce fine crystalline precipitate calcium oxalate. If ammonium oxalate is added into acid solution, oxalic acid in the solution mainly exists in the forms of dioxalate and oxalic acid, producing no calcium oxalate precipitate. When urol is added and boiled, it gradually hydrolyzes to form ammonia. The resulted ammonia neutralizes hydrogen ion in the solution, gradually reducing the acidity and increasing the concentration of oxalate. Finally, calcium oxalate precipitates out slowly and uniformly. The obtained calcium oxalate precipitate is a crystalline precipitate with particles of big size. Homogeneous precipitation method is also widely used in scientific research. For example, it has been used for the preparation of zinc oxide nanorods. At the end of the course, there is a question for you. What are the differences of precipitation conditions between crystalline precipitation and amorphous precipitation? Why? That's all for today. Thank you for your attention.